Okay, let's start digging into the details of VLM and VPX. We are on video number 2, lights, specifically the insert lamps. In this video, I'm going to be telling you how to control light maps using the VPX light objects. First of all, what are insert lamps? We'll go into that. And usually I'll start with talking about stuff that's on the table and then at the end talk about the script integration. I'm going to use Godzilla again to illustrate how to set up lamps. The inserts to start off with are special lights on the table that are ROM controlled, and they're ROM controlled through the lamp matrix. The lamp matrix is defined in the pinball machine's manual. So if you go to IMDb and search for the machine you're working on, go down here to the documentation, and usually there's a manual link, unless we're talking about Gottlieb machines, which don't have manuals online, unfortunately. But click on the link, and you will always find this lamp matrix grid, at least in most good manuals. You'll see something that looks just like this. And what this is a matrix of lamps that can be controlled by the ROM. It's a matrix because of the way it's laid out physically. There's two wires that go to each lamp, and the ROM can select which lamp to turn on and off by controlling the two wires going to it. And that's why it's a matrix. You'll notice that each lamp has a number associated with it. So it's a little hard to read in this manual, but there's this 1, 2, 3, and then it continues to go up to 56 in this case. So let's look at number 41. This is the T in the taxi inserts. Now the inserts are, when we say inserts, we mean lights that are insert into the playfield. This matrix doesn't necessarily control just lights that are in the playfield. It could control lights on the front of the cab, like the start button. It could control lights in the back box, maybe lights above the playfield, like an LED or something that's sitting above a ramp, just for example. But in this case, this table is actually pretty simple, and I think all of these are just in the playfield. So here's the T in taxi insert. I'm going to go and turn on my lamps layer. Click on the T in taxi. You'll see this is named L41. The 41 corresponds to the 41 in the lamp matrix. That's important. The index 41 is what vPinMame uses to identify that particular lamp. And just a quick note, if the manual's any good, it will lay out the position of each of these lamps in a picture nearby in the manual. And one more quick pitfall is that not all manuals are created equally. Sometimes vPinMame does not respect the index shown in the manual. Maybe the manual's old, maybe you have an old version, but just be aware of that. But most of the time, the indexes in the manual are correct, and they correspond with vPinMame. Okay, let's start talking about the properties of these lights and how they affect their control over the light maps. When you click on the light object and come over to the properties area in the visuals tab, you'll have light settings, render mode, bulb, ball reflections and shadows, and position. One thing to note about these lights is that they're primarily used to control light maps, and they'll be invisible, which means the render mode is hidden. If you come down to like halo, you'll have other properties, but we're not going to cover those because the lights are going to be invisible. However, in VPX, you can choose to still use the light to generate ball reflections. And you do this by showing reflection on balls. In the released version of VPX 10.8, there will be an option where you can still get the reflection of the inserts on the ball without this selected, and having this selected will just allow you to increase the effect of the insert lights on the balls. So if you want to use it, you can, but you don't necessarily need to. The intensity light setting really is only used to increase the intensity of the reflection on the ball in our case. And the fall off range and fall off power also just affect the reflections on the ball. So if you have that unchecked, then those don't really matter. What matters most with respect to light maps is the fader. And the fader tells VPX how to fade the light state on and off when you change its state from like a 1 to a 0. There are 3 different faders. The LED, which means there's no fading at all. When you say the light turns on, it instantly turns on, and same with off. There's the linear fader, which will just linearly increase the light's intensity from 0 to 1 and 1 back to 0 with no physical fading effect. And here's the incandescent fader. This actually is the one I always use because it best simulates the fading function of an incandescent light, where the filament will get hot real quick, but it'll cool down a lot slower. So you'll get a more realistic looking light with this fader. It's the one I recommend. You can scale the fade up and down times using these 2 parameters. I would say use something between 40 and 80 milliseconds. That seems to be the most realistic, but best is to do some research using videos online and fit the fading effect using these numbers so that it looks the most realistic. Light color only has an impact on the reflection of the light in the ball, and it seems to be most impacted by the light color. The center burst isn't really that impactful on the reflection on the ball. The bulb settings, since the render mode is hidden, I don't know if these matter, but I would say just keep the bulb not visible and static mesh. But again, I'm not quite sure if these matter with a hidden render mode. When we get into the GI lights in the next video, I'll get into more detail on the last properties here, where there's ray trace ball shadows and the position of the lights. They tend to matter a little bit more for GI. Now let's go down to the filter and search for L41. Let's pick this light map. This is the light map that affects the playfield bake map. When I click on that and select it, the most important parameter here to focus on is what's called the light map parameter, and it's pointing to L41. This is where you tell VPX that this light map is controlled by light 41, L41. The list in this drop-down includes all lights on the table, but we need it to point to L41. Now, Blender Toolkit, or VLM, automatically populates this field if Blender is set up correctly, and one of the properties inside Blender for a light object is the VPX light name. So when you set up Blender, you need to point to L41 for this light, and it'll automatically generate light maps with this property filled in. So what do we need to do to get this to work in VPX on the script side? One thing you definitely need to do is set use lamps to 1. This tells VPX to use the internal lamps functions. You need to define that before you load vpinMain. Here's where we load vpinMain using the load VPM subroutine. You interface with the ROM using the controller object, and the controller object is initialized in the table init subroutine. Now, there are a bunch of functions that have been developed and are provided in core.vbs that automatically gets loaded when you load the vpinMain. And one of those functions is called VPM map lights. And this is a convenience function that allows you to connect all of the lamp matrix lights to the ROM. You set this up in 2 steps. First step is for each light on the table that's going to be controlled by the ROM through the lamp matrix. You have to go click on the object and go to the timer tab, and you set the interval equal to the index of that light in the lamp matrix. So for light 41, the interval needs to be 41. This was developed a long time ago. It seems like kind of a workaround, but it does make it much more convenient to develop this array of lights that get communicated through the controller object to the ROM. So lamp 42 has interval 42, lamp 43, interval 43, and so on. You're going to need to go through all of them and manually update that interval. Once you've done that, each lamp that is going to be controlled through the lamp matrix needs to be added to a collection. So in this case, we have this all lamps collection. Once that's in the collection, along with all the others, you pass that collection name into the VPM map lights function. And that's done in table init. That's all you need to do. And now all of the insert lamps are connected to the ROM. That pretty much covers the insert lamps topic. I'm just going to run the table real quick. Okay, we're in the live editor. I'm going to look at this taxi light that we've been talking about. And I wanted to point out one more thing. I can, within this live editor, open up the debug interface by pressing the D button. And if I type in L41.state, well, first let's say debug.print the state of that light. Press enter. It's 0. That means it's off. We can go and we can actually update the state of the light from the debugger. I'm going to make it a 1. 1 means full on. If I press a 1, I'll have to quickly come over here and press play. And you can see it turns on. You can also see all the light maps turn on. And it didn't instantly turn on. It faded up. If I make that a 0, press enter, there it faded down. In VPX 10.8, you can actually change the state of the light to some number between 0 and 1. Let's do 0.5. That's new in 10.8. So that'll turn the light on to like halfway level. So there's 0.5. I'm going to go up to 1. There it got brighter. Now you will not have to do this with ROM controlled games, but if you're creating like an original, the light state is what you'll use to turn on and off lights, and it'll still work with all the light maps. Well, that about covers it for the insert lamps. And next video, we're going to talk about GI lamps.